So guys, here you can see one more learning came on the Python. I'm telling you about the serious video start to, and please like this video, share and subscribe to my channel, and do not forget to all the notification bell also so never show any feature related videos about the Python. So now without taking any time, let's move computer screen and let's do a coding with laughing. So guys, in today's video of Python, I'm telling you about the logical values versus single bits in Python. So yeah, in today's video, I'm telling you about it. So let's get started without wasting any time and lesson about logical values versus single bits in Python. In Python, logical values and single bits have distinct representations and uses. First, let me tell you the uses of the logical values. Now, first, it represents the truth, states true or false. Number two, it's used in conditional statements and logical operations. Number 3. Internally, Python represents true as 1 and false as 0. Single bits. Now, I have told you about the logical values. Now, I have told you about the single bits. First, it represents the individual binary digits 0 or 1. Number 2. It typically manipulated at a lower level using the bitwise operations. Number 3. Can it represent more than just logical states, and bits are used for any binary data. The one code example here we are doing like logical values versus single bits. Let me show you. Let me copy this code and let me go on my Visual Studio Code. Here I am making one new window, and when I make a new window, here I am giving my file name, it will be index.py. And then I'm making this file on my documents, save it and create. So it's saying like index.html file already agreed, you want to elevate. That means like index.html file has been already the index.py file has been already made it. Do you want to replace it here? So if in that file there is any such type of very important work, so you press no, or in that file there is not any such type of important work, so you press yes. So I'm pressing yes. So now when I paste this code here, first of all, in the second to sixth line, we define a true and false of the logical values. Then, in the 9th to 15th line, we define a logical operations, and then in the 18 to 22 line, we in the single bit we represent integers 0 to 1. Then first like by binary 1 and second is binary 0. Then the 25 till 31 we define bitwise operations. In the 25th line we define a bitwise AND. Then in the 26th line we define a bitwise OR, and the third line we define a bitwise NOT, and it inverts all the bits. Now let me save it and run it. So it give me the output like this. Like here it give me like this type of output, like logical value 1 true type class bool. Then it gave me like logical value 2 false type class bool. Then logical AND should be false, then logical OR should be true, then logical NOT should be false. Then single bit 1 should be 1 type class integer, and then single bit 2 0 type class integer. Then a bitwise AND should be 0, then bitwise OR should be 1, and bitwise NOT should be -2, and it is interpreted as 2's complement. Okay, like this, like that you can do it using this code. Okay, or you make anything using this code. Okay, or if you want to change something in this code, so you will also change it. Okay, this is your own choice. Like if you want a different thing, interpreted it as 2 complement, then give me 2 complement. Here you can see it. You also change things here if you want. Okay, if you want, it is your own choice. Okay, so like that. So now if you want to write this code, so let me tell you how to write it. First of all, you open your notepad, paste it, and then go here and let me side by side it. And then here I am erasing this code, and now here I am writing like logical value shall be 1 equals to true. Then logical value 2 equals to false, and then print f logical value 1. Then in the bracket, curly bracket, we are writing like logical value shall be 1. And then we write comma, then here we write like type, and then here we am writing type logical value 1, and then here I am writing like, now nothing I am writing now. So then copy this code and then paste this code here, and then write here 2, and then I'm also writing 2, and then here I'm also writing 2. Now perfect. So now when you do these things, now we define a logical operations. For that, first of all we write like and result equals to logical value will be 1 and logical value should be 2. And then now we define nothing. So now when we do like that, so we write like or, so be result equals to, then logical value should be 1. Okay, so we define value should be 1, and then here we define like or shall be logical value shall be 2. Now when you do this, enter press again, then write not result equals to not logical value shall be 1. Then here we define like print shall be f shall be logical and then here we in the bracket we write like and shall be result. And now when our work is done, then what we can do the same thing, write f, then logical, only you write here or, then in the bracket you write like or shall be result. Then enter press again, then again you write like print, then f, then write logical should be not in the capital letters, then in the bracket you write like not result. Then here you write like bit should be 1 equals to 1, then bit 2 equals to 0, then print shall be f shall be single bit 1, then bit 1, here we write like bit 1, and then here we write like comma type should be bit 1. Now when our work is done till here, so what we can do now, here we copy this whole thing. Okay, when you copy it, paste it, write 2 here, write here also be 2, and then 2, and then enter, then write and again, and then write here bit equals to, then bit equals to bit 1 and bit 2, and then here we define like or bit equals to bit underscore 1, then bit underscore 2. Then here we define like not bit again equals to, then here we define like bit underscore 1, then print, then f, then bitwise, and then here we define like and should be bit, and then print should be f should be bitwise, or then in the bracket or underscore bit. Now when you write this code like this, so now all code has been done. Now paste it. Now save it and run it. So this type of an output will be coming. Here you can see it like that. So here you can see it. And now key differences. First, expect representation logical values true and false bool, and single bit should be 0 divided by 1 should be integer. Then usage logical operations, and then single bit should be low level bitwise, and then type in Python bool, and then single bits will be int, then operation and or not, and single bits will be and. By experimenting with logical and bitwise operation, you can see how these concepts are similar yet serve distinct purpose in Python programming. Okay, I hope. So, but in today's video of Python, I told you about the what are in the Python, what are logical values versus single bits in Python. So, and I also write the code in the Python also. So, I hope you can enjoy this class. If you enjoy, so please like the video, share, and subscribe to my channel. Don't forget to all the notification bell also. So I will for any future related videos about the Python, and please access my Python playlist and bookmark it also. So anyways, so from now I'm using a class the next very amazing data videos. So for today, good bye.